Okay, students, this is lesson 7.3. We're going to be talking about other circle angles. Taking a look here in your packet. Don't forget a parent signature, guardian. So let's first take a shot at this review problem. It says, let me get you started. It says trace and extend the diameter KM. So there's the diameter. I want to trace and extend it. Then it says trace the arc MLK. So let's trace the arc MLK. We first want to start by finding X. And we know that this is half a circle. So we're going to start by finding X. So we know this arc, 7X plus 11 plus 8X plus 4 equals 180. Your goal is this. You want to first find X, then frame your inscribed angles and find all possible angle measures and arc measures in the diagram. I'll give you a minute to do that. Actually, 2 minutes. Find everything you can. Go. All right, so taking a look here, you should have gotten X equals 11. And then we're going to plug that in here, and 7 times 11 plus an 11, that's going to be 77 plus 11, so that means this is 88. And 8 times 11 plus 4, that's 88 plus 4. That means that's 92, which makes sense because it has to add up to 180. So now we do inscribed angles. So ready, there is an inscribed angle, trace it. And this angle back here is half of that arc right there. So that's 44. Let's try another inscribed angle. This is inscribed going this way. So trace it. That's going to be half of 92, so that's 46. And if you have your Post-its, frame up this angle right here. If you frame that up, you see that this is 180, which means this is 90. And that's true of all angles inscribed in half a circle. There will always be 90. Okay, so last class, and the class before that, we talked about a central angle. So the central angle is connected to the center. So that would be the red angle right there. That's central, connected to the center. An inscribed angle would be like this, where the vertex is on the circle and The arms are in. That's inscribed. The other term you guys know is a chord. A chord is any segment with endpoints on the circle. Now, two new words, a tangent and a secant. A tangent touches the circle from the outside. That's a tangent. And a secant is any segment that goes through the circle and intersects at 2 points. That's a secant. So you need to be familiar with all of these terms before I turn the page. A chord, a tangent, and a secant. All right, so now by the time we're done, there's going to be seven angles that you're going to be familiar with. So let's draw these. The two of them that you already know. The central angle looks like this. It's connected to the center. So put your dot in the center. And a central angle is connected to the center. So central angle, center. An inscribed angle is the vertex on, arms in. Vertex on, arms in. Those are the two we already know. Then the next five are actually named by what they're made of. If you just watch carefully, you'll see how this works. So now we're going to do what's called a tan chord. Tan is short for tangent. So draw yourself a tangent. That's a tangent. And now draw yourself a chord. That's called a tan chord. Technically, there's two angles there. There's one angle going this way, and there's another angle going that way. So technically, there's two angles there, and they're always going to be supplementary. That's called a tan chord. It's made up of a tangent and a chord. That's angle number 3. Angle number 4 is what's called a chord chord. Chord chord is literally made up of two chords. Does not necessarily go through the center. Like a tan chord, it also has technically two angles. It has an angle on the left and an angle on the right. So both of these angles, a tan chord and a chord chord, technically there's two angles involved. One of them is supplementary. The other, these are always going to be equal. Notice where the vertex is. Here the vertex is center. These two, the vertex is on for both of these. Here the vertex is in. The next three, the vertex is going to be outside the circle. Outside the circle. So let's start. Let's put your vertex out. Out. This one we're going to switch direction and go this way. There's your vertexes. A tan-tan is made up of two tangents. So watch, there's one tangent. There's another tangent. So that's why this is called a tan-tan. It's made up of two tangents. A secant goes through. It can go through or it can go through and stop, but it intersects at 2 points. Both of these are secants. And last one is a tangent secant. So you draw, or a secant tangent. So you draw a tangent. Whoops, missed my vertex. There's a tangent. And then here's a secant. So tangent, secant, secant, tangent, the exact same thing. When you are done today, you are going to know how to find the measure of all 7 angles. Okay, ready? Let's draw these. I'm going to read this. You recognize it. Okay, first one says, measure of a central angle to its arc the same. So we're going to go like this, central angle. And in this case, the angle is the same as the arc. So I'm going to write angle equals arc. The smaller angle of inscribed is half the arc, it's plane. So here's an inscribed. In this case, the angle equals half the arc. The smaller angle of inscribed is half the arc, it's plane. The tan chord angle is the same as the one inscribed. So see inscribed? These two are exactly the same thing. And the tan chord looks like this. You have a tangent and a chord. And this angle is going to be half the arc it's facing. So that orange angle is going to be half of the purple arc. And that green angle is going to be half of the blue arc. Either way, angle equals half the arc. And the way you remember that these have the same, here the vertex is on, here the vertex is on. When you have the same position, you have the same equation. Same position, same equation. So we have 3 angles, but technically only 2 equations. Next one is a chord chord. It's made up of 2 chords. Now both of these green angles, whatever they are, they're going to be exactly the same thing because they are vertical. And it goes like this. A chord chord angle's half the sum of the arcs it strides. So that means that those green angles in the middle is half the sum of the arcs. So you add those blue arcs and you divide by 2. Half the sum. And my little trick to remember this is that vertex is in, and when you bring someone into your circle of friends, you add them. Vertex is in, therefore you add. Okay, so we have, right now, we have 3 different equations. So we have 4 angles, but 3 equations. Why? Because these 2 were exactly the same. Same position, same equation. So don't freak out when we have 7 angles, because the next 3 all have the exact same equation. So let's draw them. Oops, too big. Start drawing those angles. And they are a secant, secant. So there's a secant, secant. As secant, tangent. And then my personal favorite is the tan-tan, because I think of it as like the can-can. When we talk about the angle here, we mean this angle on the outside. Notice the vertex is out. So for all of these, angle equals, it's going to be big arc minus little arc over 2. Watch, there's the big arcs. Sweep them. If you have two different colors, this really helps. Big arc minus little arc over 2. So now we're minusing. Big arc minus little arc over 2. So I'm going to write it big arc, meaning, whoops, let me keep my color straight. My big arc was green. The big arc, I'm going to use capital letters. Big arc minus little arc over 2. Big arc minus little arc. Big arc minus little arc. Okay, there, my friends, all 7 angles. Technically, there's only 4 equations. All right, my friends, I have something special for you. It's not just me singing. I have a mystery student here with me. See if you guys can't guess who's singing with me. Ready? Measure of a central angle to its arc the same. The smaller angle of inscribed is half the arc its plane. 10 chord angle is the same as the one inscribed. A chord chord angle's half the sum of the arc it strives. Secant, secant, tangent, secant, tangent, 10 angles are all the difference of the arcs multiplied by half. Woo! That would be some celebratory remarks of the very brave student who joined me singing. I highly recommend you actually pause this video and sing that or say it to yourself 3 times. Now, let's actually do some math here. I'm going to do 4 problems with you, and we're going to follow these steps. We are going to trace the angle and determine what kind of angle it is, what's the equation, and then we're going to circle, plug, chug. Trace, angle, equation, circle, plug, chug. Trace, angle, equation, circle, plug, chug. So step 1, let's physically trace this angle out. Just trace it. Great. Now, flip back to this page, and there's one. This is going to be one of these 7 angles. Match it up and name it. Try to name that angle. I'm going to pause about 20 seconds. See if you can't catch it yourself. All right. You should have said this is a tangent. This right here is a tangent. This is a chord. So this is a tan chord angle. So we traced it. We wrote the angle. Now, we have to write the equation for a tan chord angle. So you go back to this page right here. It says right here, tan chord angle is the same as the one inscribed. So there's your equation. Angle equals half the arc. So you come here and you write angle equals half of the arc. Now, we circle, plug, chug. So let's come here. All righty here. So now we circle, plug, chug. Take a look here. Our angle is what we don't have. That's our X. Equals. Trace the arc that it's grabbing. That's 200 over 2. So this right here is 100. Okay, 100 degrees. Yes. Let's try another one. Step 1. Let's trace this. Okay, we traced. Now go back to this page, try to determine what's the angle and the equation. What's the angle and the equation? See if you can't get both the angle and the equation. Okay, so once again, flip back to this page, try to find both the angle and the equation. You might have to flip back and forth a couple times. And you should have said, this is a chord and this is a chord. So it is a chord chord angle. And we know this, that angle right there is equal to the sum of the arcs divided by 2. So it's going to be arc plus arc over 2. Remember, you always write the equation first. Then you circle, plug, chug. So we're going to come over here and we pick up our angle. And our angle we don't know. That's going to be x. So we bring it down. That's x equals, our one arc is 65. Our other arc is 141 over 2. Now you want to do your math. So I have x equals 206 divided by 2. So this x equals 103 degrees. So if you go back here, not only is 103 here, but it's also going to be on this side because it's vertical. So once again, how are we tackling these? You trace, angle, equations, circle, plug, chug. I'm going to set the timer for 5 minutes. I want you to follow these two completely on your own, and I'll come back in 5 minutes, and we'll go over them. I'm actually recording.
What you have the last people.
All right, let's see how you did here. So this one, this is a, trace it, it is a secant, 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 secant. So for this one, it's going to be that angle equals big R minus little arc over 2. Now we circle plug chug. We actually have the angle this time. That was 46 equals our big arc is 134 minus, and this time X is our smaller arc. This is over 2. Bye, guys. We're going to put this over 1. We're going to cross multiply. We end up with 92 equals 134 minus X. Basically, that's going to be 134 minus 92. And we're going to get 42 here. So X should have equaled 42. Now let's try the one on the right. On the right, it is a tan-tan. And most of you, if you got stuck, it's because there's supposed to be 2 arcs, but I only give you 1. You have this arc, and then you need this arc. The trick is they add up to 360. So we're going to go 360 minus 265. And you get 95 for that other arc. Now we come over here, and this was a tan-tan, because it's made up of 2 tangents, so this was a tan-tan angle. And this one is angle equals big arc minus the little arc over 2. So our big arc here we don't have the angle, but our big arc was 265. Our little arc is 95. And that's going to be over 2. So we're going to do 265 minus 95. And we get 170 divided by 2. Therefore, our angle equals 85 degrees.